So this is the video A for proportional relationships. One of my favorite math topics in your I can statement is I can write the rule of an input-output table as an algebraic equation. So you're actually going to be doing some algebra today. Isn't that exciting? I love algebra. Okay, so here's the first example. Write the rule of this input-output table over here and complete the table. So the first step when you want to do something like this is to think this question. How does the input number become the output? That's the question we need to consider. Because remember, this over here is like a number machine. So we have input numbers, or numbers that are put into the machine, and then something happens to them, that's the rule, and they become the output number. And so we have to think, how is our input getting to the output? How is 1 getting to 3, 2 to 6? Well, you're right, if you're thinking times 3. I want to show you how to write this algebraically, though. So we know the rule is times 3 or multiply by 3. Okay. So there's lots of ways you could write it, times 3 or multiply by 3. But the algebraic way of writing it is 3x. Now this x does not mean the multiplication symbol. So what I mean by that is this x here actually it means the letter x. And whenever you have a letter next to a number, it means the number times whatever the letter is. So in this case, 1, because it's our x value here, would go right in the place of x, and it would mean 3 times 1, and we get our 3. Let me explain that in a little more detail. Here's the real algebra part. It says, write the rule as a relationship between y and x. Okay. So to show this relationship, we have to say that y equals, so this number y, and let's do 2 and 6 as an example here. This number y equals 3 times whatever the x number is. So let's test it out. 6 equals 3 times 2, because that was our x number. So 6 equals 6. It works. So this is one algebraic way of writing 3 times the input. Because just as a general rule, we use the letter x for the inputs and the letter y for the outputs. Let's do 2 more quick tables, and I think that's going to help us fully understand how to write these as algebraic equations. All right, same kind of problem here. What in the world's going on to my x's to get them to y's? Well, it looks like we're multiplying by, I think, -2, right? -4 times -2 is 8. Let's see if it works for this one. Always test it on as many values as possible. Yeah, negative times negative is a positive. Anything times 0 is 0. Okay, so this must be -6. And let's see. If I'm timesing something by -2 to get -16, that means this must be a +8 over here, because +8 times -2 is -16. So I always check on as many possible options as possible. I always check, let me re-say that. See how we have 2 sets of numbers here? I always check the rule on every set of 2 numbers I have to make sure that it's correct, to make sure that multiplying by 2 works for every single one. Because I could have said -4, maybe +12, but that didn't work for this step here. So that's why you got to test your rule to make sure it works for every single one. Okay, so now we know -2 times x, whatever x is, gets us our y. So we write it as y equals -2 times x. Let me explain in a slightly different way. Whatever y is going to be depends on what x is. This is a dependent relationship. When and only when x is -4, y is 8. When and only when x is 3, y is -6. For example, if I put 3 in the place of x here, I get y equals -6, and that's exactly what I have in my output value here. So it's a dependent relationship between 2 variables or 2 letters. That could be really any number. But there's a rule that gets us from the inputs to the outputs, and that rule is described right here. Let's do one more, then you're going to try these by yourself. Okay, same thing, but in this case, we have to think, okay, this looks a little different. what in the world could the rule be? And sometimes when you're trying to find the rule, you're going to have to guess and check. Well, right away, I kind of see that my numbers are getting, looks like they're getting cut in half. So I have a clue right there. It almost looks like we're dividing by 2. And so how would I write that as a rule? Well, whatever I'm doing to my numbers in my x column to get them to my y column, I do that to the x in my formula. So because I go -4 divided by 2 gets me to -2, and so on and so forth. 16 divided by 2 is 8. 14 divided by 2 is 7. And 60 divided by 2 is 30. Because I see that rule, I do the same thing to x in my equation. So y must equal x divided by 2. So whatever number x is, I could plug it in and I could get the correct corresponding y value. I could also write it like this. This is a fine way to write it. It means the same thing. But I just want to check it. So let me check it with these values. Okay? My x number is 16. So y equals 16 divided by 2. So y should equal 8 if my rule is correct. And it does indeed equal 8. Therefore, I know I've written my rule correctly. So again, guess and check a few times. Make sure your rule works for everything that you can see, and then write it as a relationship between y and x. And I know you're going to do a great job.